Alright, so now what we can do is go ahead and start wiring up all of our electronics. We got the pod out of the way, and we can start on the flight controller. Now, I was going to wait on this build for the new Betaflight F4, but to be honest, the F3 does me more than good, and I honestly only run like 4K, 2K. I don't see much point in running anything faster than that as of right now. So, but I'm not going to get into all that. What we're going to do is go ahead and build this. So the way this will sit on here in my case is just like that. Wait, nope. Like that. Board's going that direction. And this is the nose. Tail's back here where you've got the LiPo connection. Now, I'm hoping that eventually, which I was actually going to try by just putting another carbon fiber, I have one around here somewhere. Where'd it go? Oh well, I can't find it right now. But I have another carbon fiber bottom brace, and I was going to see about putting one on the top, because I'm not using this PDB at all. I'm just using the PDB is all in the BFF3, and it seems like more and more boards are going to the all-in-one style configuration in one way, shape, form, or another. So it'd be kind of neat if they started selling just delete plates that were the same shape but cut out of carbon. But as of right now, this is what we got. So we are going to just be using this for all of our connections. It does make things a little bit more difficult as far as getting wires tucked down, but it does work, and it works good enough. So, but that's the way it's going to go. So what I'm going to do is I'm going to flip this upside down, and we are going to tin all of the wires, or all the pads, I mean. We're going to get everything tinned. We're going to put our wires on and make them a little long. That way we can then flip this back over, and we can start tucking our wires down to where they need to go. So, let's get started. Alright, so that's all the bottom pads tinned up. Now for this setup, I'm going to be using these motors, which are the Xnova Lightning 2206 2600 kV motors. I love these motors for racing. Yes, they are kind of, well, they're higher kV. These motors are great motors. They are the, I believe they only weigh 26 grams a motor. Titanium shafts. They're just awesome motors. I've been through some crazy wrecks with these motors. I have not bent one. I've not had one go bad in any way other than I burnt one up, and that was my own stupidity. So, these are awesome motors. I love these motors. They have a ton of power. And I like to have that little extra RPM at the top to get myself out of trouble if need be. But these motors are a little bit power hungry. I believe I have pulled on an uncalibrated Betaflight board 169 amps, and I know for a fact that board, that setup reads a little high. But due to that, I'm using 16 gauge power and ground wire from the PDB to the ESCs. I've looked into it, and if you're really wanting to get the true output of what your ESCs are capable of, which in this case I'm using these here. Oh, that's not an ESC. These here, Ray 32. These are the 35 amp models. They fit perfectly on these arms. As far as ESCs that can handle those motors, you ain't getting much smaller than that for this setup because of how small these arms are. And these have a 50 amp peak, and if you actually are hitting that, you're going to need a wire that can handle it. Yes, you could probably get away with 18 gauge and you wouldn't see much of a difference in performance, but I'm running this just because I know it works and it works well. So this is what we're going to go ahead and solder up to our board, and then we can flip the board over and start working on the other side. Now, if you are using a BFF3 board and you have it upside down right now, I highly recommend doing the jumpers on the bottom of the board, these here. There's these little jumpers right here, and one is for the RAM pin, and one is for the what is it? The it's for the receiver pin, whether you're running 3.3 volt or you're running 5 volts. So make sure you jumper those now, because if you don't, you're gonna hate yourself later when you have to try to get up underneath the board and jumper them. So we're gonna go ahead and do that real quick. Now, I've never had good luck with running 5 volt off the RAM pin. I've always gotten really dirty voltage for some reason off of it, and I don't know why. So I just run, the way we have this set up here, we're running 5 volt to the camera off of the UNIFI Pro. So I just jumper this for 12 volt, and we just run the wires from this to the RAM pins and power the UNIFI off that. So we have RAM jumpered to VBAP. That is weird. Oh, I see. Alright. Looked like they both said 5 volt. Tiny, tiny writing. Alright. So we now have 5 volt jumpered, and we have the VBAT jumpered on RAM. Just clean that up a little bit. There we go. Alright, and it seems how this is about the last time we're going to see the bottom of this board. Take some alcohol and a little scrubby, and we're just going to clean up all of that flux off of where we did the jumper. And we'll do this again once we finish off our ESC wires. Alright, so now I'm just going to go ahead and solder up all of the ESC wires. Alright, so my battery decided to die, and no, your eyes are not playing tricks on you. This is a new mat. They had these self-healing mats on sale for like a dirt cheap price at a local store, and I just couldn't pass it up, so I picked one up. But anyways, back to what we were doing. We are going to start doing all the soldering up all of the power wires from the flight controller / PDB to the rest of the quad. So what you're going to do is strip back positive and negative wire, tin your leads, and then solder them to your board. Now I like to lean these up a little bit. I'll get this other one on here and I'll show you why. So I have these leaned up, and that is because when you flip this over and you put it down here, these need to go under the arm. So you're actually wanting them to go down, but we're doing all this upside down because they decided to put the pads on the wrong side of the board. So you're wanting them to be at a slight angle up for all of these, so that once we flip it over, they go down, so you're not putting a really sharp bend on these wires. Just trying to help the wires go in the direction they need to go, which is important on this setup due to the fact that these wires are pretty short and we're running a heavier gauge wire to support the motors, and there's not a whole lot of room to work with, so every little bit helps. So I'm going to go ahead and finish up the rest of these. You're just going to want to cut off about, I would say, 3 to 4 inches. If you're unsure of how much you need to cut off, you can go ahead, put the board in the regular position, fold your wires around, and cut them off extra long, because on some ESCs, positive is going to be on one side and ground's going to be on the other, and then it's going to be reversed on some of the other pads for the other ESCs. So you want to make sure you cut these long. So I usually go out to about the middle of the arm, which is, like I said, about, each one of these squares is an inch, so about 3 inches. So we're going to cut these, solder them up, and then we'll move to the next step. Alright, so now that we have all of our power leads going from the flight controller / PDB out to go to the ESCs, we've made sure we've done our jumper pads for the right connections that we're going to be using on the other side. The only thing left is to do the power wire on the bottom, and then we can go ahead and flip this board upside down, or right side up actually, and take care of the ground, and everything else will be taken care of on top of the board. So for the power wires, I use 12 gauge wire for my power wires from the LiPo to the board. Some of this may be considered overkill by some, but for the peak current that this setup can actually pull, this is what you're going to want to be using. Also, the bonus to using slightly oversized wire is that wire is soldered to the pads and can help dissipate heat. So if you're not overheating these wires and these wires are constantly staying cool, these larger wires can actually help dissipate heat from the board. So it's another reason why I use slightly larger wire versus using slightly too small of wire. So we're going to go ahead and strip these, solder them up, and then we can go ahead and flip this board over. Now, it's very important to not allow any solder or flux or any stray wires to fall off the side of this board, because your negative is on the direct other side of the board. So if you have anything jumpering between this side and the other side through the small gap that's here, you can short out your LiPo connection, and that's not good. So you want to be very careful with how you hook these up. I push this as tight as I can on the silicone up against the board, and same on the other side. That way I don't have to worry about there being any stray wires or anything jumping over. So just keep that in mind when you're soldering up the power tabs on the BFF3. Alright, so now that we have the positive wire taken care of and all of the ESC wires, our jumpers are taken care of, we can go ahead and flip this board over. There's nothing else we're going to have to do on the bottom side. So now that it's flipped over, you can see how what I was talking about earlier in the video about angling these up. So now that it's flipped over, they actually angle down. This will help keep the wires tucked nice and neat to the side. It's not as important in the front because of how much more space it is, or how much more space there's there before they have to fold around. But on the sides, it's very important because the body comes down directly along the sides of these wires, and if they shoot out at all, there's going to be a much sharper bend here, and you take the chance of having the Lexan come down and actually cut into these wires. So, and I have a trick for some of this as well, which we'll go over once we start doing the rest of the build. But so now we'll be working on the top of the board from here out. So we'll go ahead and tin up all of our connections, tin all the pads up. Alright, so now that we've got all the pads tinned for ground and signal, the ground for the LiPo in, we've tinned all the wires for our receiver and tinned all the wires for the RAM and ground, which will go to the VTX, as well as video in and video out from the camera and VTX. Now that that's all taken care of, we can go ahead and start running our signal and ground wires, and we'll then run the ESCs, hook them all up, and then we'll take care of the pod last. So before we get too far here, I'm going to go ahead and get these wires taken care of for the LiPo. That way I can cut them to length, and we're not fighting with these long LiPo wires. Alright, so now that we have all the connections made on the bottom, and we've gone ahead and tinned everything on the top, we can go ahead and clean the bottom off, and we'll be done with the bottom entirely. So you just want to take a brush, some alcohol, and just go in and clean up all your connections and get rid of any flux. Alright, so let's go ahead and wire all these up. Alright, so now we have all of our wires for the ESCs done, and they are all soldered up on the PDB/flight controller, and we can start wrapping them around and running them to our ESCs. Now, I found a trick on this quad, on these wires. They're going to wrap around and go under, is how I'm going to run these on my setup. And an issue you can have is the pod will come down and try to cut these wires. They're ran underneath, and what can happen is another quad can slam into you, or you can hit a gate. You can actually crimp these wires across the carbon, or a prop strike from another quad can come in and hit these and cut them. So what I have found that works best is to slip some heat shrink over all of these wires, just enough to get it up underneath the bottom. It's going to be kind of in the way and a pain, and it's stiff. It doesn't want to bend like these silicone wires do. But once we have the ESCs up underneath and mounted, you can then heat up the heat shrink, and it will form to the curve that you've put into the wire after mounting everything up. And that thick heat shrink will actually protect these wires. It's much stronger and harder to cut than the silicone on these wires are. So that's a trick I have found. I also do the same thing on the motor wires. As you'll see on these motors, they all go the same direction out. So I do the same thing on those to protect the motor wires from getting cut from a mid-air or from slamming into a gate, because you obviously, it's a racing quad, you're going to crash it. So I'm going to go ahead and mount this board down, and then we can flip it over and start working on all the ESCs. So again, the ESCs I'm using on this build are the Wraith 32. These are the 35 amp version. They're a little bit narrower than the 50 amp version. They're just all around smaller, and it's more than enough for this setup. So the nice thing about these Wraith 32s, and I don't know why all of the BL Heli 32 manufacturers don't do this, but they put a very bright LED on these. And one of the bonuses to BL Heli 32 is there's an LED controller right in the software. Now right now it's just a simple click, turn on RG or B for red, green, or blue, and you can mix them to get whatever color you want out of this LED, but I have a feeling that in the future they're going to give us more control over what we can do with the LEDs. But these are very bright, and most people think I actually have LEDs on my quad, but in fact it's just these simple little LEDs on the ESCs. So it's pretty convenient. It makes it so you don't have to mount a whole nother set of LEDs on your quad if you want to fly at night, or if you have any night races that use LED gates and stuff. It makes finding the quad a lot easier. So kind of a neat little convenient feature that BL Heli-32 has. Now, I don't think all of the ESCs have them, have the LED anyways, but the Wraith 32s have them, and it's a pretty cool little feature. So let's go ahead and mount these guys up. Alright, so I'm going to go ahead and tin all the pads for the flight controller to ESC side, and then we will go through the process of how to mount them to the arms. Something to note about these ESCs, and a lot of the newer ESCs are done this way, is they have full wraparound pads. So the pads fully wrap around, and there's an issue with doing this. It's a great feature to have all the pads wrap around, but the issue with doing this is a lot of guys like to just mount their ESCs to their arms and wrap them in electrical tape. It's very good to put something like double-sided tape or foam between the ESC and the arm, which a lot of people do, but not everyone makes it the full length of the ESC. And what can happen is the tip of these pads, if they come down in contact on either the positive side or the motor side with the carbon, it's going to arc. So you have to be very careful and make sure that you either wrap these in heat shrink entirely from end to end, or at least wrap them all the way and then cut off the top, because I know a lot of racers like to leave these leads exposed so they can easily swap out new ESCs. But it's important to make sure the bottoms of these are protected, whether you just wrap your arms in electrical tape or you put foam full length across these. I use double-sided tape for the full length of the ESC, and I usually put foam in here as well to just get as much padding between this and the arm. That way, if there is some kind of prop strike from another quad, or you hit the gate goofy and the ESC gets slammed into the arm, there's some padding there to protect the components and stuff from getting broke off. So just be aware that the pads on both sides, you have to have the bottom side covered so that they do not make contact with the carbon, or you're going to have a bad time. So, alright, so now that we got the ESCs all tinned up, what we're going to go ahead and do is cut up some foam. This is just a piece of foam that comes in the lid of the Xnova motor boxes. It's a little on the thicker side, but if you peel it off right, you still have a little bit of stickiness to put down on the arms. So this stuff eventually starts compressing. I'd rather have it be a little thick and absorb more impact than be thin and have broken ESCs. So what we're going to go ahead and do is cut some strips out of this that we can put on the arms, and then we'll start soldering up the ESCs. Alright, so I like to just take these and lay them out on the frame. Like I was saying, they have a little bit of stickiness on the back, which is nice, because you can just stick them right in place. Next thing you're going to want to do is lay out the ESC and pay close attention to which side's positive and negative, because that's going to determine how you actually wrap these wires around and which one needs to be longer than the other. So in this case, positive is on this side, so our negative needs to come out and around. And I try to leave these a little bit longer, just because there's a nut right here that you need to get to, and one of these days I'm going to get around to drilling these little holes here on the bottom plate out and seeing if I can get these press nuts to actually press into the carbon there, because it would make removing the pod just a million times easier. So if ever I do that, I'll make a video on it so you guys can see if it works or not. Alright, so now that all of our wires are cut to length, we can go ahead and start stripping the wires down, and we can tin all of our wires, and then we can lay our ESCs in place and start. I normally, what I'm going to end up doing here is just I'm going to tape these in place just with a little piece of tape so they don't move, and then we can solder them up and then remove the tape. We'll heat shrink them, and then we can move on to hooking up the motors. Alright, so what I've gone ahead here and done is I've just used a piece of tape, electrical tape, to secure this in place temporarily while I go ahead and do all the connections, and then I can peel this off. So I'll do this and move the tape around to each one and get all the ESCs soldered in place, and then after I have all of the wires, including the signal and ground wire for the signal, all of them attached to this side, I'll go ahead and peel this off. I'll heat shrink them, and then we'll work on the motor wires, and then I'll secure the ESCs down permanently after all of that's taken care of. So I just do this. It's not necessary. If you want to hold this in place and try to bend the wires up and solder it, which technically you need 3 hands to do, feel free, but I do it this way just to make life a little bit easier. So I'm going to go ahead and take care of all these ESCs, and then we'll start working on the motors. Alright, so I almost forgot to show you guys this little trick that'll save you a lot of headache in the long run, and that is I'm going to take this heat shrink that's big enough to fit all these wires in, and I'm just going to cut short sections about 1 inch long and run them on the wires. It does make it a lot more difficult to bend these up into place, but once you heat shrink this down, it'll help hold the form of the wires, and it'll protect the area going around the arm. So if another quad hits you, or you hit something and it smushes these wires into the frame, it'll keep these wires from cutting and arcing onto the carbon. So you want these between like 3/4 and 1 inch long, and you're just going to cut 4 of them, 1 for each ESC wire. And like I said, it makes it a little bit more difficult to wire these up, but it's better than having one arc out and fry an ESC or ruin your frame or fry your flight controller in the case of a crash. So I try to do as much preventative stuff in my builds to make it to where I can fly, and nothing sucks more than being at a race and having a mid-air or a simple crash that hits something just in the right place, and it ends up ruining your whole day because now you can't fly. So something as simple as a piece of heat shrink in the right spot can help prevent that, then I'm going to do it. Alright, so you can see now that it's all heat shrunk down. It holds this nice and firm line up to the ESC, and it also protects it from getting cut on the carbon or on the PDB or from the Lexan on top. So just a nice little bonus there to help protect the wires so you don't have a bad day in the event of a crash. So, and then I'll do the same thing for the motor wires up here as well. So I'm going to go ahead and take care of the rest of the ESCs. We'll get heat shrink on them and get everything prepped to take care of the motors. Alright, so we got the ESCs all mounted up, and I just wanted to go ahead and show you guys how I have the heat shrink. And like I was saying, once you have it all the heat shrink heated up and shrunk down, it will start to hold everything in place. So those wires will start to have a natural form and hold themselves in place. Now I'm going to go ahead and solder up my XT60. Normally I would have soldered this up first, made the pigtail, and then connected it here. But That's not how things went on this video, but that's how I recommend doing it, is actually soldering up an extra long pigtail to the XT60 first, and then cutting it down and soldering it to the board. Alright, so we are all set, ready to go for motors. I went ahead and put the XT60 on here. Take note, I have this zip tied down to the PDB. You're going to want to have this zip tied nice and tight, because in a crash you will end up throwing your LiPo, and this will protect your board from getting destroyed. Much better to have this wire get screwed up, and it's much easier to replace than it is to replace a whole flight controller. So make sure you have this zip tied down nice and tight to the PDB, and we're ready to go for motors. So you can see I got all my heat shrink pushed down and pushed farther over. I'm going to go ahead and wire up the motors first, and then we can slide this back over and heat shrink it down so we can protect all the wires, both bottom and top. And then what I normally do is, if I ever need to replace a motor, I'll just cut off the top section here, so that I can unsolder the wires and solder the new ones on, but it keeps the heat shrink on the bottom side to protect the other side of those pads so they don't make any contact with the carbon. So we're going to go ahead, I'll mount the motors up. So these are the motors I'm using. Awesome motors. Xnova Lightnings. Super light, super strong. The only issue I've ever had with one is burning it up, and that's usually my own stupidity that causes that. Alright, so let's get these beasts mounted up. Now they can only go in one way because we only have the 2 bolt holes to put these in, and they're particular spacing. I believe they're the larger of the 2 spacings, so you can only put these on one way. They won't go on the other way because the spacing between the other 2 bolts is too close together. So these will all go in the same direction. So there it is, bolted up. Then what I'm going to do is extend some heat shrink all the way up to the heat shrink that's already here. We're just going to extend it a little bit longer. So we'll get these folded up to our ESCs, something like so. And then I'll extend some heat shrink through here to protect the wires again, so we don't crush them on the carbon in case you, this is the front. So if you were coming in and you hit something here and it smushed these wires up against the carbon, it can put cuts in them. And also whatever you're hitting, let's say you rear end another quad, or it's this motor back here and a quad hits you, we want to get as much protection on these wires as we can get. Anything we can do to prevent a small issue that is either going to be a repair or could completely ruin your day by burning up electronics, it's best to figure out a way to prevent it now, to keep it from happening entirely, than it is to have to repair it and then think of an idea of how to fix it. So we're trying to get rid of any issue we could get so that this thing is as indestructible as possible. Alright, so now we have our pod and our receiver all soldered up. So all of our connections are done. All of the soldering side of things are done. You can see how I laid the pod off to the side and I did all my connections for it to go that direction. This way you have more room to work with when you go to take the connectors out. The other nice thing about the XSR is one plug and the whole receiver comes out. So if for some reason you needed to, it's always better to have an extra receiver on hand in case something gets messed up, like an antenna, and you can just swap the whole receiver out if you're in a pinch, and swap a new one in, and you're good to go. You can go back out and fly, and then you got the old one that you can fix if it's fixable or repairable, and then you have that as a backup. So that's the other nice thing with the XSR. So all that's left now is to mount the XSR, and the way I do that is I'm going to stack up some double-sided tape, and I'm going to put the XSR right on top of the flight controller, just using some double-sided tape. Make sure you stack up enough of it and orient it in a way that none of the chips on this board touch anything on this board. You want them to just basically hover on top of one another with the double-sided tape in between. So I'll go ahead and do that now, and then we're good to go. We can put the body on, we can get the USB holes cut out, and then throw it on the computer and get this thing in the air. Alright, so real quick, I wanted to make sure you guys put some heat shrink over the XSR. It gives something nice for the double-side tape to stick to, and also protects this from shorting out on your flight controller, because we are sticking them right on top of each other. It's a racing quad, it's going to crash, stuff's going to bounce around. I've never had anything, an issue with sticking anything with double-side tape to another board. You just have to make sure you put enough double-side on here to protect it so it's not vibrating around or anything. So we'll get that mounted up now. Alright, so that is how you mount that. Just some double-side tape, and I put it across the whole back of this just so that it keeps the boards from resonating or vibrating against each other if there's some extra padding between there. So I've never had an issue doing this. It works great. All my builds are usually pretty noiseless. If for some reason you did have a lot of noise and you couldn't find where it's at, check that, make sure that it's not touching something that's hard, like another chip or the USB connector or anything like that. So now what we're going to go ahead and do is get our body mounted, but first things first, before we go too far with this, it's not a bad idea to plug in. I've gone ahead and cleaned off all the connections on the top. You want to remove all the flux and stuff from those. So take your smoke stopper if you have one. This one here is just a really low volt or low amp fuse that I plug in, and then you can plug a LiPo in and make sure everything works. And it's not a bad idea to go ahead and bind your radio at this point. Alright, so we got the radio in bind mode. And this is the part that's always nice to have 3 hands. So go ahead and push down our bind button and plug in. Alright, so we should be bound now. Go ahead and plug in. And we do have bind. And if you get anything funky like that going on, it's usually because the stock configuration for Betaflight is goofy settings. And it might be set up for one shot or what have you, and the minimum command that the flight controller is currently giving out is enough to turn these motors over. So don't worry, but that's why we don't put props on when we first plug in. So alright, so everything's good to go. We can get these antennas mounted up. We can...
Telemetry lost.
Alright, so we got the pod mounted, we got the receiver mounted, we're bound. I'm going to go ahead and bolt this flight controller down the rest of the way. We can get these antennas mounted. I'm probably going to use some zip ties and get them mounted in a situation like so. That way we can get the full amount of diversity out of them. I have some small antenna tube that I usually use. Let's see if I can pick this up. This here, we'll go ahead and mount these like this. I'll probably use either the tube or zip ties so that they're mounted in here. You can also mount them up in the body. It's just a little bit more of a pain to take the body on and off when your antennas are mounted up inside of it, but that also works pretty well on these builds. But yeah, we're going to get all that stuff taken care of, and then we can go ahead and hop over into Betaflight and get all of our ports set up, get our radios set up, and then we can test fly it and start some tuning. Alright, so we got the pod on. You can see how I did the antennas. I'm at the point right now where I'm going to be cutting out my USB connection. So I need to get in here for data logging to get to the SD card and for the USB. So what I'm going to do is drill a couple bullet holes here with the reamer and just get them started, and then I can connect the dots with a X-Acto knife, and we can go ahead and get this chunk knocked out right here so that we can get to all these components. So we need to get to the SD card and that USB connector. So I'm just gonna drill a hole like here, 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 and here, and then we'll just chop out a nice little square. That way we can get in there, and then I usually use these here so I can grab the SD card and pull it out and put it back into place. So we'll go ahead and get that taken care of, and this makes life just a lot easier. It does kind of take away from the nice clean pod, but it's a racing quad, and function is a little more important than fashion. Alright, so one last thing you need to do before you put this body on, and that is we need to put on a battery strap. So the battery strap on these goes across the top of the PDB and between the flight controller. And you just want to make sure you run that through. Get it pulled where you need it, and then we can go ahead and put the body on, or the pod. Alright, so these are the socket head screws with the washers. Push them straight down. And then the black lock nuts are what go on under here, and this is why we didn't mount the ESCs yet. This way we can actually fold them up out of the way and install these nuts. I almost forgot battery pad. So I like to pull these little knockouts out. You can leave them in, you can take them out, it doesn't really matter. I think it looks cool without them. This battery pad's actually pretty cool because it's very squishy and thick, and it allows you to get your battery strap tight without crushing the battery or pulling it extra tight, because you get this extra pressure of this battery pad always pushing, and it's very grippy to the battery. Will it keep your battery from getting ejected? Not really, because if you crash hard enough, you'll just break the whole battery strap off. It doesn't matter what you put on there, it's coming off. So, but it is really nice, and in most crashes it stays on. So now everything is done. The only thing we have left to do is tape these ESCs down, and we're good to go. We can go and start programming BL Heli to get our motor direction the right way. We can, first thing I'm going to do is plug it into Betaflight, get everything running, and then once we can arm and see what our motor direction is, we'll go from there to get the motor direction in the right direction, and then we can go ahead and program these LEDs.